Hey guys, welcome back. This is just going to be a quick reminder of the different types of formulas for area and volume. And if this review isn't enough, remember there are other videos. You guys can just go directly to my YouTube channel, search my name, Karen Derflinger, or find it within the modules for area and volume, okay? So here we go. Okay, first, you need to make sure you know which graph is the one on top, okay? So if this is, make sure you figure out which one's which. Let's say I'm making this one up. So let's say this is f of x, this is g of x. You also need to know these points of intersection, and you need to know how to do that both by hand and with a calculator. Okay, well, let's make something up. Let's say that this is the point, I don't know, it's the point 1, 2, okay? All right, so first let's talk about area. To find area, you find the length of one strip. Well, that length right there is f of x minus g of x. Okay? Then, to give this strip, instead of being just a strip, I want it to be a rectangle with an infinitely thin width. So we call that dx. Now this is the area of one little strip, an infinitely thin strip. But that's not the area of in between these curves. I want all of the strips that go from here over. So we're going to add this one, this one, this one. I'm going to add all of these infinitely thin rectangles, and that addition symbol is the integral from 0 to 1. Okay? So basically for area, find one length, f of x minus g of x, and then the integral turns it into area. Okay? This is one dimension. This gives it the area dimension, second dimension. All right, now volume. So area is just top curve minus bottom curve. Okay. You could, by the way, go sideways and do it in terms of y. You could do slices this way and integrate from bottom up too. All right, now let's do volume. Let's say we're going to take that shaded region. We're going to spin it around the line y equals -2. Okay? Since there's space between my shaded region and the axis of rotation, this means you have two r's. We're going to say big R squared minus little r squared. Big R squared minus little r squared. And my bounds would go from 0 to 1. But I haven't even talked about that yet. So there's two r's because there's space between the shaded region and the axis of rotation. Whenever there's two r's, make sure you draw them. Go from the curve to the axis of rotation and go from through the shaded region to the axis of rotation. Big R, little r. Little r is touching the shaded region. Big R goes through the shaded region. Okay? All right, so next. Big R squared minus little r squared. Make sure you write that. Okay, now r is always the distance from top to bottom. So in this case, it's going to be f of x minus -2. F of x minus -2 or plus 2. Little r, top to bottom. That would be g of x minus -2 or g of x plus 2. And you are allowed to leave it like that if you don't have to solve it by hand. Okay? All right, so now what is the case when you would have just one r? When does that happen? Well, that would be a graph that maybe looks like this, where the shaded region is flush up against the axis of rotation. Okay, that would be pi big R squared. Okay, where r would just be the distance from here to here. Okay, last, volumes by cross section. So for volumes by cross section, you find the area of whatever the slice is, or the cross section. And sometimes they even give you the formula for the area of the slice, so be warned. So they give you area, and then you integrate area to turn it into volume, okay? So just like for area, we took one length, one dimension, and then the integral turned it into area. Volume, you take area and integrate to turn it into volume. Okay, I know I'm being a little bit vague because you should already know how to do this. This is just a quick reminder. So if you need more detailed videos, look up some old ones, okay? Now there's one more thing I want to review for this, and that's actually integrating by hand. The two problems I give you today, 2011 and 2013, They are non-calculator questions. So I want to make sure we go over integrating without a calculator. Okay, this is a common type of integral for you to do by hand. So if you're confused about the pi, or if there's anything funky in there, always refer to an easier problem. The integral of this would be negative cosine 5x divided by the derivative of the inside, plus c, unless we're doing a definite integral, which you usually are. Okay, so this is the same thing. This would be negative cosine of pi x divided by the derivative of the inside, which is just dividing by pi. Okay? All right, now let's step it up a little bit more. What if it was the integral of sine of 1/2 pi x? Well, you can either think of that 1/2 pi like that, or you can think of it as pi over 2. Either one, whatever you think is easier. Okay? So we're going to integrate, get negative cosine of 1/2 pi x divided by 1/2 pi. So we're dividing by 1/2, which will be the same as multiplying by 2, and dividing by the pi. Or if you see it like this, then it's obviously dividing by pi over 2, which is the same as multiplying by the reciprocal. Okay, this is pretty common that you'll have to integrate like that by hand. Your free response questions, remember there are 2 calculator questions. There are 4 non-calculator questions. Okay? So to summarize your different formulas that you're going to need. Area is just the length between the curves, top curve minus bottom curve, and integrate. Okay? Volume, if there's any space between the shaded region and the axis of rotation, then it's big R squared minus little r squared, and integrate. Volume, if there is no space between the shaded region and the axis of rotation, oh, I forgot the pi, duh, is pi just big R squared. And last, volume given cross sections. It's the area of one slice or cross section. And then integrate to get volume. Okay, it's pretty vague, but if you need more details, again, look at the other videos. Hope that helps. Keep asking your questions. Okay, guys? Thank you.